used a large language model? And it's a trick question because I think almost everyone has. An example of the use case would be Google search. If say you want to understand something about how Siri technologies work, you go ahead and bring out your phone, you start typing in, and before you even finish what you're looking for, you start getting these suggestions, both in the browser from the Google search itself and from your keyboard. So there's a race over here to understand what you're actually looking for. And then once you finally click one of them or hit enter, you get a result like this. This result kind of is a summary and right at the top of like what you're looking for. And it seems to be pretty accurate to the question itself, right? Even though I just searched Siri technology, it knew that it has to describe Siri technology to me. And then when you click on that, you end up going to the next page in there. And that page kind of has this highlighted section, right? Which was kind of what was summarized in the starting. So my question to everyone is, which of these steps do you think actually uses some form of language processing or the other? Step one, step two, or step three? Actual perception is that all three of these use language models in some form or the other. You have your keyboard, which has a very lightweight language model that is used to predict the next word. You have Google that's trying to predict it based on a bunch of other criteria. You have summarization of sort that gives you the output right at the top in a very concise summary. And when you click on it, it actually goes and selects the part relevant to it. But I'd argue there's another part over here that's kind of abstracted away and isn't very visible to us. It's a step called 1.5. It actually uses semantic search to give you the relevant results after looking through a large corpus of data. We talked about auto completion, we talked about semantic search, text summarization, and question answering. This is just 4 different tasks that a language model was used to do to actually get you a result. So you can understand how these technologies that we regularly interface with use language models in these complicated manners that we generally don't have a very good understanding about. Another really cool use case that I personally use a lot is when you're writing emails to someone and you get like a response recommendation at the bottom. It's kind of concise and short, but it's generally pretty useful for a short reply to people. And what happened, what got us to this point, right? So in 2013, there was a paper and blog articles and a bunch of really exciting news about this model called BERT, B-E-R-T. Why was it exciting? Well, it was the first time that Google found a way to train these language models at large amount of data, ended up giving pretty significant results. It was a huge leap in the understanding of what models can do previously and then what models can do right now. And then there was another leap which led to more recent trends, but we'll come to that in a bit. But why was this exciting? Why was this something that ended up being so groundbreaking? Well, for 20 years, Google engineers focused their talents on trying to optimize search and make it better and better. 20 years of effort was then almost entirely replaced by this one model that ended up just understanding language better than any deterministic programmable solution we had earlier. This was also then put into production within a year or so, which proved how easy it was to just bring machine learning models into production and actually solve realistic problems in production with them. So that was pretty fascinating. So we've talked about the different language processing and language-based tasks that these models can do, but I'm here to argue that it doesn't just limit there, right? We have different modalities like vision, audio, robotics that can actually go ahead and get improved by these language models. So when we're talking about language processing with vision, we have multiple interesting use cases. One of them very trending last year was the image generation case, where you had models like DALL-E, Midjourney, and Stable Diffusion actually generate pretty good images based on fairly simple prompts, right? So it took like that English, it got semantics of that and then built a visual understanding that it had to create these images. And this is very powerful technology. But before that, if you go back a few years even more, you would see that like these tools were being used in conjunction